Hello, this is Roberto and this is the HVAC, it's my channel. Today we're going to be talking about Wrightsoft heat load calculation for condominium part 2. Alright, so let's get into it. So in the previous video, we were talking about the steps. Step number 1 is to get very familiar and also very comfortable with the drawing, with the floor plans. In other words, you have to get to know very well the drawings. So we did that in the previous video. Now, step number 2, and I'm going to put it in here as a reminder. So, that's not going to be blue. This is going to be, we're going to make it this in green. All right. So we're going to put this step number 2. So for step number 2, we were saying, let's go check the location. Okay, location is very important. Location. And this is also for people that live outside of the United States. So if you live in India, you live in Dubai, you live in Africa, every place will have different weather stations, weather locations. They will have different insulation values, but they still need insulation, right? So in this case, based on the location, so we're going to put in here as an example, Fairfax, Virginia, VA, Virginia in the United States. Okay. So based on that location, number 1, this is also very important. So if this is a house, this is a house or a condo unit that was built in the past. So if you're a contractor and you're planning to replace the unit, and then you need insulation values, and the homeowner says, what is that? I don't know what is insulation value. And if you cannot perform a heat load calculation like that, then you have to check code. So in other words, so since we have the location in Fairfax, we're trying to see that the insulation values, but you need to check also on the year, right? So this unit has been built like in the 1970s. Let's put 1975. In 1975, the energy codes were not that strict. But every year they are requesting adding more insulation values. They are requesting to be the houses to be more energy efficient. So in 1975 it wasn't that much. So in other words, this house is not built for a good. It might not have very good insulation. On the other hand, sometimes they do renovations, they update the windows and everything. That's why it's very important to know the insulation values. So since this is the year, now we're gonna have to check in here. Okay, so we know the location. Okay, Fairfax, Virginia, especially in the US in this case. So in the USA, based on the location, you're gonna look for the following. You need to check for code, but where are you? Because we're trying to go to step number 3. We need the envelope values, which is the U factor, solar heat gain coefficient for the wall, ceiling, floor, and everything. So in the United States, when you don't have those values, you have to go to use a conservative approach. So the conservative approach is going to conservative approach. All right, means you're going to check on the code values approach. All right, let's go check on the code. So for the location in Fairfax, what is the applicable code? So where do you find the envelope values? Is it in the International Mechanical Code? Let's check envelope values. Okay, where that's the main goal, to find the envelope values. In this case, what we're saying is we need the ceiling. Okay, we need the ceiling R value. We don't know. We need to obtain the wall R value. We need to obtain the floor R value, right? We need to obtain the windows. When you're saying about windows, you need the U factor and solar heat gain coefficient. And for the door, you just need the U value. All right. So you need to obtain these envelope values in order to perform your heat load calculation in Wrightsoft, load calc in anything, right? So now where do we get these values? It's very good if you have it from the architect or the homeowner, but if you don't, we're gonna check for these envelope values in code. But which code? In United States, there are a lot of codes. That's why the location is very important. Location, Virginia, Fairfax, or California, or Alaska, or any place. We're gonna go check in here, go to the internet. As we saw in other videos, we saw that based on the location, a very good resource is actually upcodes, right? So what we're gonna do in here is gonna be the following, all right? We're gonna up this, okay. And then in there, what we're gonna put in here is upcodes. Upcodes, Virginia. There you go. So whenever you put upcodes Virginia, you're gonna be able to find the applicable codes in this state, right? Or if it's in another country, resort to the local authorities, or they might find something, okay? So in here we have a lot of codes, international building code, residential code, we have the existing building code, plumbing, fire. In which code, see, there's so many. In which code are you gonna be able to find out the envelope values? The code is in the International Energy Conservation Code, okay? That's where you get the envelope values. So every state is adjusting the values to depending on the state. So in this case, they call it Virginia Energy Code 2018, which is based on International Energy Conservation Code 2018. Okay, now here is the second thing. So now we know that we need IECC 2018. All right, let's put it in here to the side. So now we found out, I'm gonna put that as in white. We found out that based on location, we need the IECC, which year? 2018. All right. So since it's the 2018, just let's remember there are 29, IECC 29. There is 2012, 2015, right? 2018. 2021. So actually Virginia is right here. But there is an issue with that because this house is existing. This condominium is already built. It's not a new construction. So if you were making this as a new construction, you have to apply these minimum insulation values 2018. So the R values in the table that you're gonna find in this code, you have to comply at least with those R values, where you need a lot. You need a higher number of insulation or R value, right? So in 2009, you have not less requirements, but the values are lower. For example, let's say your exterior wall. In 2018, you might need an R value minimum of R21 for the exterior wall, but in 29, you might need an R value of maybe R13. See, there's a big difference. R13 for the wall or R21 for the wall. Of course, when you put more R value of insulation, you pay more. So we'll see. Since this house has been built in 1975, we're gonna be conservative and we're gonna assume that we're not gonna go to IECC 75 because I don't even know if that exists. So we're gonna go for this low. Even we can go lower, but let's try to see 2009. Okay, so how are you gonna find this code? IECC 2009. So the way you can use that or find out is if you go to the internet, you have this already. See, you just type International Mechanical Code 2019 and luckily you're gonna be able to find this online. So this is the, see in here, this is the International 29 International Energy Conservation Code. Okay, so we're going to be able to find in here our insulation values. So you can buy this book or you just can check it online. So if you go online, in here you have chapter number 4, because in chapter number 4 it says residential energy efficiency, and this condominium applies for residential purposes. But if it's a mixed use building, you're gonna have to use commercial energy efficiency. Commercial. So we're gonna go for the residential. So you click on chapter number 4. And in chapter number 4, you have all this information. So in here in chapter number 4, you go directly to table. The table is table 402, right? So let's go check. This is table 402, section 402. Okay. Let's keep on going down. See, section 402, building thermal envelope, prescriptive. All right. Okay. So prescriptive. There is the table 402.1.1, right? Okay, so now you need, in order to see the insulation minimum requirements are depend on the weather location. I mean the climate zone, especially in the United States. That's how it works in here. So what is the climate zone where Virginia is located? So even if you don't know the climate zones, you can always go to the internet, and then the Department of Energy will give you a map of what are the climate zones. For example, let's put in here climate zone map. There you go. What is the climate zone map? See, you just go to Google, and then you're gonna be able to find this map right here. So this map will show you what is your climate zone. So if you are located in Virginia, which is right here, see climate zone number 4. Number 4 who? 4A, right? 4A. If you are located in California, you have again number 4, but in this case C, right? You have B for dry, A for moist, B for dry, and then C for marine. If you live in Miami you have number 1, climate zone number 1, right? And then in here it explains to you, it explains where also is located Hawaii, Puerto Rico, and everything. If you live in New York or close to Canada, you have climate zone number 7. So this is a good map to use in order to see the climate zones. Okay, that helps a lot, honestly. So now we're gonna click out, we're gonna go here. So our climate zone is climate zone number 4 in here, as you can see in here, except for marine. Okay, so in this climate zone number 4, what is, I need my wall, ceiling, and floor. Okay, so for my wall, what is the minimum? As you can see in here, fenestration requirements by component. Climate zone number 4, fenestration is for the windows. So for the windows, we're gonna need the following. I'm gonna take notes of this, and it's gonna say, windows, the U factor says U factor 0.035. You need a minimum U factor of 0.035. The lower the U factor for windows, the better. Of course, more expensive, but the better. Okay, but at least you have to comply with that. Okay, U factor, you have it in there. What is the solar heat gain coefficient for the windows? It says NR. The requirement is NR. Well, I'm not trying to get away with what is NR, right? So NR means not required. So it doesn't matter for them. So in our case, let's just put a solar heat gain coefficient of 0.2. No, 0.3. In here it says 0.3. Let's do 0.3. It's conservative, right? Now let's go for walls. We have windows already. Let's go for walls. What is my exterior wall? Right here, I mean the next one says ceiling. The ceiling R value that is minimum says for climate zone number 4, it says R38. So I'm gonna put in here for ceiling, we need an R value of 38 at least. But remember, this is 29 IECC. In Virginia, they have 2018. So in this case, I must say that the R value for the ceiling might be R49 or it's or higher. No, this doesn't pass code currently. But what we're trying to do is we're trying to be least energy efficient. And in other words, we're going to upsize our unit somehow, right? Later in the video, we're going to see that. Okay, the ceiling is going to be R38. Next one is going to be frame wall R value. So for the frame wall, so it says wood frame wall R value is number 13. So I'm going to put for the wall is R13, which is low. Usually is R15 or R21. Okay. Now we're going to go for the floor, which is how much? Floor R value, it says 19. However, in this case, we don't have a floor, honestly, because we're in the middle. But if we live on the first floor of the condominium, we're going to go for a slab. Right here, it says a slab. R value and depth. So what is the minimum R value for the floor? For the floor is going to be R10. And then the depth is going to be 2 feet. There we go. That's all we need, folks. However, let's study a little bit more on this. What if you live in climate zone number 5 and 4, marine zone 4 and marine and climate zone 4? See, marindo. So in this case, what you have is the following. See, in here it says this one. This is the one that I want to use. So for the wood frame R value for the wall, you have either two choices. Either make your wall R20 or make it R13 plus 5H. Well, R20 means continuous cavity insulation. However, when you do it 13 plus 5 means 13 is the cavity and 5 is the continuous insulation. All right. So you can also see it as H. In here you can see H. So H, you go here to the notes. What does H say? 13 plus 5 means R13 cavity insulation plus R5 insulated sheeting in here. So and they explain to you a little bit more about it. Okay. Alrighty, and also for the basement, if you're gonna have a basement, you have in here R10/20. So what does that mean? In here it says R10/20. So that means R10 continuous insulated sheeting on the interior, but the exterior home has an R13. So as you can see, the energy code tells you everything. All right. So now what we're going to do is we're going to put these values in where we want it, like right here. Okay. So let's put it in here because actually we're going to be using these values. So from IECC, so we're going to put in here, let's go back to normal. Let's put in here green. So IECC 29, because the building is old, we're going to be very conservative. We're going to put a wall. Okay, for the wall, we're going to need R, as we were seeing, R13. Okay, for the ceiling, we're going to have R, which R, it was R38. Okay, and the other one is going to be for the floor. For the floor, we have R10. For the windows, we're going to have U value equals, the U value equals 0.35, and the solar heat gain coefficient equals 0.3. Okay, the door we'll do later. We're gonna put, usually for the door, we just keep it at R6. All right. Already. So now this is so now you have the envelope values. Now we can go back. Now we can go to Wrightsoft actually. So we're gonna input these values in Wrightsoft and we're gonna apply it. However, let's be curious a little bit. So if we have R29, what does IECC 2018 says? Let's just be a little bit curious in here. So if we're gonna go there and then we're gonna put in here back, and then we go here, International Mechanical Code, International Energy Conservation Code. This doesn't work. IECC 2018. If we're gonna go to the 2018, which is the real one, we're gonna go here and then where is residential? In here, existing commercial chapter commercial energy efficiency. Okay, energy conservation code, general requirements, residential provisions right here. Okay, in residential energy efficiency, let's check what is the envelope in here. So they're asking for at least, instead of U035, the U factor for the windows is 0.32. Okay, for the solar heat gain coefficient 0.4, and as I was saying, see, for the exterior wall it's asking for R20, not R13. R20 for the slab, R10 the same. For the ceiling, R49. That's good, but in my other code it says R38. All right, so remember, this is very helpful because anytime you're doing a heat load calculation and you want to be very well informed, you need to know where this is coming from, just to give you more idea. And anytime that you want to explain to the customer, you have more input, more tools to let him know this is how it works. It sounds way more professional. All right. Okay, so now we did step number 2, and then we did in here step number 3, which is the envelope values. Step number 3. Okay, in the next video, what we're gonna do is we need to import these drawings, but there is an issue with this drawing, with this floor plan. This is not in scale. It doesn't have any scale. So that's why in the floor plan, if I import it, it might not work. So in that case, I might have to draw it room by room, which is okay too, because in here we have the dimensions for every single room. So it can work easily in this case. Lastly, this R value for the wall only applies to the exterior or exposed wall. We don't worry about the internal walls. We don't worry about the partition walls because they're all conditioned. All right. I hope you enjoyed this video, and don't forget to hit the like button. That helps a lot, and subscribe and share. All right. I'll see you in the next video. Thank you for watching. HVAC is my channel.